Hello everyone, welcome to this 31st session on switching theory and logic design. Myself Dr. Sohail Rana, and we are discussing Boolean algebra. So today's session we will see some computation of gates, and we will also see the Boolean expression and logic diagrams. So let us begin with today's session. Today first we will discuss some insights of logic gates. So here let us see how to get the total gate input count. So suppose we want to find out the total count of the gates input, right? So if our expression is in SOP form, then what we will do, we'll count the number of AND gates, number of AND inputs, and the number of, say, AND gates feeding the OR gates. And if the expression is in POS form, then what we will do, in POS form we will find the number of OR inputs and OR gates feeding to AND gates, number of these gates. And here we will, AND gates will feed to OR gates, here OR gates will feed to AND gate. And if it is hybrid form, then we will count the gate inputs and the gate feeding other gates. Because why we need the count? Because cost of implementing circuit cost is almost like it's proportional to the number of gate inputs required. So the gate count is one kind of important parameter which we have to consider. So let us see, let us see one example on gate input count. The example is how many gate inputs are required how many number of gate inputs are required to realize the following expression, So number one is, say, F1. It is given as ABC plus AB bar CD plus EF bar plus AD. So first let us solve for this first one, then we will see the second one also. So here what we will do, say we will write down the expression and first we will count the number of AND gates. So this is our expression. So how many AND gates? First we will count the AND inputs. AND inputs for this one we have 3, plus for this one we need 4, for this we require 2, for this we require 2. So these are total 11 AND inputs we require. Then we can count the AND gates feeding these are AND inputs. Now we have to see the count of the AND required to feed OR. So how many ORs are there? 1, 2, 3 OR. For that we require one gate for ABC, one gate for AB bar CD, one gate for EF bar plus 1 gate for AD, total 4. So this is the total will be equal to 11 plus 4, that is 15. So these are the total number of gate inputs we require. Let us see next example. Say next one, we have to find out the total gate count required for, say, B. This is F2 is equal to A into B plus C plus D bar into B bar plus C plus E bar into A plus B bar plus C plus E. Now here what we have to do, we have to count the OR inputs. The first stage is to count OR inputs. So OR inputs, first of all here we don't require any OR. Then for this we require 3 inputs. Then second one, for this we require 3 inputs, and for this we require 4 inputs. So this is total 10 OR inputs. Now we have to see the count of OR gates. Those will be connected to AND gate. Now this is AND operation. This is AND operation. This dot is AND operation. So for this AND operation, here we require 1 OR. Addition is OR 1. So next we require, for next one more require OR gate. Then here also we require 1 OR gate. Then for this also we require 1 OR gate. So that will be 4. The total count is 10 plus 4, 14. Now let us see how to convert the Boolean expression to the logic diagram. So let us see converting Boolean expression to logic diagram. Now we can realize Boolean expression as hardware components using gates. So hardware can be translated into Boolean expression and for the analysis of existing circuit. So what we can do, the easy way to convert Boolean expression to a logic circuit is to start with the output and work toward the input. So say we will start from output and then we will move towards the input. Now let us take one example. So say we want to draw the logic circuit for a given expression, that is AB bar plus A plus B plus C whole bar. Now this is our end expression. So let us begin with the output. Say this is my output. This output I need this output. So output should be AB bar plus A plus B plus C whole bar. So at the output all of them are getting added. Added means here I require 1 OR gate. So this is OR gate. At OR gate there are input coming from 3 places. So one input is coming from some place which is AB bar. Second input is coming directly from A. Then third input is coming from B plus C bar. Okay, so one by one we can add what is required. Suppose now we will focus on from where we are getting this AB bar. So remaining two will keep as it is. So AB bar and say B plus C bar, they should be coming from some inverter as complement. So say if I am giving some AB input to one inverter, and there it is going becoming AB bar. A is as it is, so no need to modify. Here I am giving some input B plus C to one inverter, so at output he is giving B plus C bar, and all of these three are coming to this gate and giving us this output. Now this AB is coming from some AND gate because it is multiplication, and this BC, B plus C, is coming from some OR gate. So what we have to connect here, we have to connect one AND gate, and here we have to connect one OR gate. So let us redraw it. So how we will get? So A and B, if we give to AND gate, the output is AB. This output, if we give to NOT gate, at the output of NOT gate we get AB bar. Then second input is A as it is, and this one will come from here. This is A. Now another B plus C. B plus C is either we can give this same line, we can connect, or separately we can show one line, say B plus C means we have to connect one OR gate. Output of this will go to, here we have B plus C. At the output of inverter we get B plus C bar, and this input will connect to OR. So this output is our final output. So we have found out opposite from output to input. Now similarly we can convert the logic to Boolean expression. So for drawing diagram we started from output and then we reached to the input. Now similarly, if some diagram is given, we can convert it to some Boolean expression. So that also we will see in example. Now one more thing what we have to discuss is we can convert AND or invert logic to NAND NOR logic. Let us see this one more conversion from say AND or invert to NAND NOR logic. This is also called as AOI logic to NAND or NOR logic. In the designing of digital circuits, the minimal Boolean expressions are usually obtained in SOP form or POS form. Sometimes the minimal expression may also be expressed in hybrid form. The SOP form is implemented using a group of AND gates whose outputs are odd, and product of sum forms are implemented using the group of OR gates whose outputs are given to AND. The hybrid form is combination of both SOP and POS. So sometimes what happens, the complement of a function which we are implementing, and we have to design the circuit which can be implemented using and OR gates only as and OR logic, or using and or not logic. So it is called as AOI logic. In the realization of Boolean expression, the variable and its complement are assumed to be available. So for example, say the SOP expression for, say, let us take one example here. Say SOP expression ABC plus AB bar plus A bar BC can be implemented in AND OR logic. So how we will do, say first we have ABC. Okay, ABC input will give, say A, B, C. Here A, B, C, all of them are ANDed. Then next AB bar. So here we will give A, here we will give B bar, A, B bar. The B bar is coming from some inverter where we are giving B. So this is AB bar, this is ABC. Then third one, we can have, say, A bar, B, C. All of them are connected to OR gate. So all of them are connected to OR gate. So this expression is here present at the output. Now in POS form, what we can use in POS form, say in POS form, suppose the expression is, say, A plus B plus C bar and B plus C and say A bar plus B bar plus C. We can implement using OR and AND gates. Say how it will get. So this one will get as the first A plus B plus C bar. So this will give inputs A, B and C bar to OR gates. Then this B plus C will give to another OR gate. Then this A bar, B bar and C to third OR gate. So this is A, B, C bar, this is B, C, this is A bar, B bar, C bar. Now all these outputs will connect to one AND gate. So here we will have one AND gate. At the output, this overall expression will be there. Now if we have some hybrid form, so let us see some hybrid form. Say in hybrid form, we have one expression A, B, C bar plus A bar, B so this is, say, B, A bar plus A bar, C. So first, say, we will see the AC bar. This AC bar we will have AND operation. Here we will have, say, AC bar. So here we will have output is AC bar. Now this should be ORed with A bar. So here we connect one OR gate. Second input is A bar. So at the output of this we have A bar plus AC bar. Now all this term should be ANDed with B. So this one will AND with B. So at the output we'll have this expression. So like this hybrid logic can also be reduced. So with this we will stop this session, and the next session we will see some new topic and examples. Till then, have a good day. Thank you.